Good morning or good afternoon, and welcome to lesson 3 of module 1. Today we're going to learn about what happens when we raise a number that is written in exponential notation to another power. Okay, so you know you're successful today when you can successfully do that and simplify these expressions. So let's go ahead and get started. All right, here is our rule that we are learning today that I just spoke about in that first slide. In my opinion, it's always easier to see this actually done with numbers instead of variables. Variables just always kind of throw me off. So instead of showing you this example, I'm just going to show you with numbers. So say we have this number 3, and it's being raised to the second power. Okay? And it's in parentheses, and then it's being raised to the, let's say, third power outside of that. Well, how do we simplify that? What we do is we do 2 times 3. That's going to be our exponential notation now. So it's going to be 2 times that 3, so it's going to be 3. We always keep our same base to the, what's 2 times 3? 6 power. So basically all we're going to do is multiply this out. And here's the reason why. If I were to show you what this actually looks like, this looks like 3 times 3. And we're doing this whole thing 3 times now. So then we're doing this a second time. And then we're doing this a third time. And you can see that's a total of 3 being multiplied by itself 1, 2, 3, 4, 5, 6 times. So again, that's why we just write it as 3 to the 6th power. Okay? I want you to have this down just so that you can see it. So literally everything that I just drew, please draw that on your screen or write it on a piece of paper and then upload it to ClassKick. Because like I said, the way they show it with the variables right here, it's a lot harder even for me to understand. It's a lot more abstract. So literally everything they showed you right here, I just did right here with the number 3 and then those 2 exponents. Okay? And once you have that down, we will move on. All right, based on what we just did in that last slide, we're going to get into this. I'm going to do maybe one of these for you, and then I want you to practice doing them on your own. So I will do exercise 2. So it looks like we have a -2, and that -2 is being multiplied by itself 5 times, and then we're taking that whole answer, and we're doing that 8 times. So as we know with these numbers and working with exponents, those parentheses matter. I'm going to keep this -2 in parentheses, okay? And then I'm just going to do 5 times 8. Well, 5 times 8, that is 40. All right? And then I'll do exercise 4 for you as well. This is just a variable. It says let S be a number, so let's just pretend that's a number, and that's our base. And it's being raised to the 17th power, and then we're doing that whole group 4 times. So I'm going to do 17 times 4. You can do it in your calculator if you want to, but I'm going to do it by hand. 4, 5, 6, 68. Okay. Go ahead and do exercise 1, please, and come up with your answer. Take about 20 seconds to do that. It's really only one step. You can do it in your head. And you should have came up with 15 to the 9 times 3, 27th power. And please do exercise 3. This is a decimal, but it is the same thing. All right, so you keep your base of 3.4, and then you're raising it to the 17 times 4, 4 times 7. We already did this right down below, but 28, 4 plus 2 is 6, so the 68th power. All right, moving on to exercise 5. It says, Sarah wrote 3 to the 5th, then raised to the 7th power equals 3 to the 12th. Correct her mistake. Write the correct answer. So if you look at this, what did she do wrong? Please message me in the chat if you can figure it out. What did she do wrong here? Well, you should have noticed that she didn't multiply the 5 and the 7. She added them. So mistake added the exponents. And the correct way to do it is to multiply them. And so the correct answer would be 3 to the, well, what's 5 times 7? 35. 3 to the 35th power. Okay? You'll notice that I don't keep these parentheses that are right here. And the reason being is that those parentheses are just acting as a multiplication sign. They're separating the 5 and the 7 in order to multiply. If they want us to keep the parentheses, they'll do something like this, where it's parentheses within parentheses. Okay? All right, we're going to actually skip exercise 6 and then move on to the next page. Let's continue on. All right, our new learning for today. If a number is already written in exponential notation, so say we have 5 to the 4th power, and is raised to another power, so this whole group is raised to another power, we simply multiply those two powers together to get our simplified answer. Okay? Make sure you have this down. This is our new learning. This is the new shortcut rule we have learned for today, and we're going to continue practicing as we move on. All right, here's the next part of this new learning. Basically, if we have two numbers, so we have a 5 and maybe we have an x, okay? And it's being raised to a power. We can distribute that power to both numbers within the parentheses. So here's what it would look like. The 5 would be raised to the 3rd power. And then the x would be raised to the 3rd power. And we can remove those parentheses to simplify it. And then we could even simplify this further. Okay? So 5 to the 3rd power, we could actually solve that. 5 times 5 times 5. Well, that is 125. And we can't simplify x to the 3rd power because we don't know what x actually is. We could rewrite it like this. And so this would be the most simplified version of our answer. But we couldn't get here unless we knew this rule, is that you can distribute your exponents. Okay? Please make sure you have this written down so you can reference it as we move throughout the lesson, okay? All right, getting into some practice with this, we're going to be distributing our exponents when there are multiple terms within our parentheses. So starting with exercise 7, this 9 would be able to go to both the 11. This becomes 11 to the 9th times, and then it would go to the 4 as well, 4 to the 9th. Okay? Obviously, if we were actually solving this, we would continue to actually work that out. And then let me show you exercise 11 as well. So, exercise 11 is a little bit more complicated. 7 is going to go to the 5, so we have 5 to the 7th. The 7 is going to go to the x. You'll notice I didn't put a dot between them. I don't need it because that's a variable, not a number. Okay? And then the 7 is going to go to this y. Now this y already has an exponent. So what do I do? Well, it already has a 2 attached to it, and I'm trying to attach another 7 to it. Again, the rule we learned today is that we multiply those. So 7 times 2 is 7 to the, or y to the 14th. Okay? I'll do one more with you. I'll do exercise 12. All right, and I'm actually going to zoom in a little bit for you. So the first one we're going to do, we're going to give this to our first term, which is this a. Now the a already has a 2 attached, so I need to do 4 times 2. This becomes a to the 8th. All right, then I'm going to give it to this b. This b has nothing attached to it, so I just give it the 4. And then I'm going to give it to the c. C already has a 3 attached to it, so I have to do 4 times 3. That is 12. All right. So please go through it now. Do exercise 8, 9, and 10. And we'll go over them in just a moment. All right. All right, looking at exercise 8, we have two terms. We have a 3 and a 7, and they already both have exponents. So I'm going to take this exponent, I'm going to give it to my 3. So I have to do 5 times 2 to get my total number of exponents there. So this would be 3 to the 10th times, got my 7, giving my 5 to that 7. It already had a 4, so I'm doing 4 times 5 to the 20th. All right. Exercise 9. This 5 is going to my 3. It already has a 2. 5 times 2 is 10. And this 5 is going to my A. It already has a 4, so this becomes A to the 20th. Number 10. The 7 is being distributed to the 5. And it's being distributed to our X. All right, check your work with mine. Make sure you have those answers down. The last one we want to do here is basically saying, well, what if we raise something that's a fraction to a power? What do we do with those numbers inside? Well, this is essentially saying that we're going to do this whole thing, x over y, so many times. We're doing it n times. We're multiplying it. That means that we're going to have this many x's and this many y's in. And so this is the same as saying x to the nth power over y to the nth power. And we'll learn more about this later on. Just wanted to make sure you have it down before we move into our closure and exit ticket. Okay? All right, our closure today. If a number is already written in exponential notation and it's being raised to another power, we simply multiply those powers together to get our simplified answer. So this one will be 2 to the, that's 2 times 4, 8th power. Okay? If an expression written in parentheses, so maybe 5a to b, is raised to a power, let's say we raise this to the 5th power, we distribute that exponent to each term within the parentheses. So we have a 5, so this is going to be 5 to the 5th power. So we distribute that 5 to this. Then we're going to have it being distributed to this a. The a already has a 2, so we're doing 5 times 2, so this would be a to the 10th. And then we're going to do this b. The b has nothing, so this is just b to the 5th. Okay? Again, we distribute it to every power within those parentheses. All right, if you feel confident with this, we're going to move into our exit ticket now. Here's what your exponent looks like today. Number 1, you're taking that 9 to the 3rd and raising it to the 6th power, so simplify that. Number 2, you have a longer expression. Some of these numbers already have exponents within them. Okay, so keep that in mind, and you're raising this whole thing to the 3rd power. Number 3, you're doing the same thing, but with variables this time. Number 4, again, you have all variables, even your outside value is a variable. I want you to see what you can do there. And then number 5, we have 4 to the 8th power divided by 5 to the 8th power. I want you to really think about this one. This kind of brings us back to our lesson from yesterday, or the day before yesterday, actually. And these are all going to be multiple choice in Galileo, so take your time, show your work. And again, these are in Galileo, so please head over to there and get this done. And then when you're finished, please work on your lesson reflection that's posted in Google Classroom.